Welcome to today's video. I will be talking about the problem Canada tour. So in this problem, we're given a few points and we want to visit them in the ordered, starting at the leftmost, basically at the leftmost city, and then going down to the rightmost city, and then we want to return back without going through any cities that we've already visited. So we're basically asked to find the longest path that can make us go all the way to the end and come back. And here, instead of thinking, we can think of this problem as two people starting at the beginning and walking to the end, but both of them are taking different paths. And for example, in this problem, you can think of this as both people starting at Vancouver, and then they will take a few series of moves throughout this whole graph, and then both of them will finally end up at Halifax. So we can use dynamic programming to solve this. I will use a 2D array. The first value of this array will represent where the one of the person is, and then this is the second one where it represents the second person, where the second person is and ended up at. So this is basically the ending point of two people, and finally we should find one that will make us end up in the final city. And to keep track of the cities or points, since it starts as a string, I will convert this into an integer, give it a few positions using an unordered map. So then this way we will be able to store the points easier using integers. So here, whenever we're reading 2 points, we will give them an undirected edge between them, and then here we'll start using dynamic programming. So first, this is the first case where we just stay at the first city. This is the base case if we cannot we cannot complete any full cycles without visiting multiple cities that we've already visited. So this will just be 1. And what this means is basically if you just start off at 0 and also end at 0, then of course you will have only one city visited. And then we will use a few loops inside. So I will represent the position of the first pass. So this is the path which we are taking to get to the we're going to the eastmost city. And then this J will represent basically going from the eastmost city to the westmost city, or going back from the end to the beginning. So here we will loop through all of the positions before J and check if there's a path between K to J. So if there's a path from K to J, then that means we can visit K on this path when we are starting at 0 and going to J. So we can use K, but we also have to make sure that it is possible to reach K. So at first here, I'll set everything inside this DP array to be 0, other than this beginning 0, 0, of course. So here we have to make sure that it is possible to reach this K by checking IK. So if this is not 0, then that means we've had some possible moves to visit K. Then we will get the maximum of our current dpij with the dpik plus 1. So this is because we can find a path starting at a city or from city K to point J. So that means, and since we're visiting point J, this means that we have 1 extra point visited. So this is why we do plus 1. And loop through all of the cities before J, because we're coming from the west and going to the east. So then after we finish this will give us basically the current maximum cities that you can visit if you start at if you are going to I and then going back with city J. And this will also be the same as with these two variables flipped over, because this is just one of them is greater than the other, so they will both have the same value. And then here we will check if it is possible to visit the final city or the eastmost city if we are currently at this I. Or this I is our first pass. This is our actual pass. We're actually going from the west to the east. So what this basically means is that there's a path from this current point I to the final point, and that means we can see what happens if we take this path from this current point to our final point. This means that we would have been able to reach all the way to the end of this tour, but this is only for the first half, because we still need to return back to the beginning, and this is the other half. So this is why we use this dynamic programming. We will check what our I n minus 1 is, because here my cities are 0 indexed. So here we check the final city, and we get the total maximum cities or points that we visited during this tour. So we will get the maximum of that, and this answer will initially be 1, because this is the default case if we don't visit any other city other than the first one. So for every I, we will check if there's a path from I to the final city, and get a maximum of all of those DP values. So finally, you can just print out the answer.